I'm doing a little more work on this old Dr. Fong amp again. I got the left channel board out of it, and I've been testing everything, and so far all the components have been good. I haven't tested the op amps, but I can't really see anything on this board failing because I don't think any of it works very hard. It's got a pair of 2N6306, a 2N3584, and 2N6211. Bunch of 0.33 ohm emitter resistors, and a pair of 0.18 ohm. I believe those are just let's see, yeah, they're in parallel with each other there. We've got two fuses, one for each of the power supply rails. I haven't checked to see how many amps they are, but I know they're blown. All the resistors are good, and everything else seems to be in really good shape. I've also been going through all the output transistors and testing them. And the funny thing I noticed, testing them on my transistor analyzer here, and a lot of them are measuring with a gain of over 200, which was over the specification of a max of 150 on a brand new one. And some were measuring really low, like under 30. And I think the minimum is like 15 or 20 on those. I'll have to look at the data sheet again, but they're definitely not gain matched, and they probably should be. So I'm going to get some new ones, and if I have to, I'll replace all of them on that channel so that they all match. The emitter resistors can only compensate for so much. That seems like a big difference in gain between those. And like I said earlier, two of them were just plain shorted out. But not as bad as I thought it was going to be. I thought the driver circuits were all going to be toast and everything was going to be a nightmare to get apart, but it wasn't so bad. Only a few wires really. Most of it stays in the casing over there. I'm also going to increase the bridge rectifier to a 35 amp. It's only got a 25 amp in it right now, and try to get a soft start circuit installed, basically just a thermistor that limits the inrush current, because this thing sure pulls a lot of juice on power up. And it probably wouldn't hurt to put some bigger filter capacitors in either. Only 10,000 microfarad is not a whole lot for an amp this big, so. But first order of business is to get some new output transistors in and get this channel reinstalled. I'm going to go through and test everything on the other channel too after I make sure the amp is working. Making some good progress now. Both channels are up and running and they sound great. Got the Panasonic FC capacitors on the driver boards, and that really helped the sound quality. It was really muddy sounding and not very loud, even on the one working channel when I first got it. But last night when I put it all back together and powered it on, it immediately blew a pair of transistors in the back again, just like it had before. And that's when I discovered something interesting. I was troubleshooting, looking for shorts, and I discovered that the speaker jacks are shorted to ground when the amp is turned off. So I looked at how this relay was wired, and I discovered that they have it set up so that it grounds the speaker outputs during the power off and power on transient. And you know, I guess that was kind of a dumb way to implement that, because it was completely shorting the output stages for a couple seconds on power up. And of course, without that relay, there's a big power on, power off thump from the speakers. In fact, I'd call it more of a boom, because I mean, the power supply rails are plus and minus 100 volts, and as soon as the power goes away from those op amps and they get DC offset, the speakers just go kaboom. But what I'm going to do is rewire that relay so that it opens the connections to the speaker jacks while it's not energized, instead of shorting them, and hopefully that's going to take a lot of strain off these transistors. The ones that blew were actually just some ones I was using for testing, some generic ECG transistors. So I got to order some of the proper MJ15001 to replace it, and check the DC offset and see how the bias is between the two channels. I don't want to mess with that if I don't have to, because I don't have the service manual or schematic, so I don't know what the bias is really supposed to be. So I just got 2 more caps to replace on the protection board there, and maybe tie up some wires, and this thing is ready for some cosmetic work. So sounds wonderful compared to what it started with anyway. And in fact, at 8 ohms, I can't even really tell that there's 2 transistors missing, because it's just not enough current to put a strain on it. It doesn't even need the fan, because the heat sinks are running so nice and cool, even without the airflow. So coming along real well. Let's see where we end up with it anyway. Alright, I've got that relay all rewired now to work properly. I really want to know why they did it the way they did, but anyway, had to use my Dremel tool to cut some traces to the relay and reroute them and all that good stuff. But check this out. No power on and off kaboom anymore. It just works. I'm really surprised that these capacitors have held up all these years, running right at their voltage rating, and you know, with no inrush current limiter or anything. Even the original bridge rectifier is in good shape, but I did put some thermal paste on it before I remounted it, so it'd run a little cooler. And yeah, I'm glad those caps are good, because they're $100 a piece, and I only paid $100 for this whole amp, so I've already got to buy $20 worth of output transistors to finish up the left channel, but it still rocks the house like it is. Not bad, not bad, especially the condition it's still in.